Hello, boys and girls. Good morning, good morning. I mean, good afternoon, not good morning. We are meeting after 12 today. Hello, everybody. Very good afternoon, all of you. Hello, 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 hello. Am I audible and visible? Can everyone see me and hear me properly? Hello, everybody. Come on, boys and girls. Hi, Chaitanya. Hi, Snehita. Hello, Prashanti. Good morning, good morning, good morning. How's everyone doing at home? Enjoying the hot classes in the hot weather within the comfort of your homes. Good afternoon everyone. कैसे हो भाई सब लोग? How's everyone? Ilao Naru. Very good morning, very good morning. Good morning. Come on, show some energy in the class. Why is everyone looking a bit tired today? I am good. Jainath. Sorry, not Jainath. Good morning, boys and girls. Today state results came. Good afternoon, good morning. Okay, chalo, shall we start? Thank you so much everyone. Hello Ajay. Hi Sukumari. Hello Kamakshi. And if I miss some of your names, then please excuse me. Okay? Once you are here, then I will know everyone by their names. Don't worry about that. Okay, so shall we start? Paper, may you have any doubts? I have the paper with me. Somebody said that they want to discuss some atomic structure question. So just give me a minute. So which question is that? Ram. Namaste. Rishvita, how are you? Good morning. Yes, Lucky, what's your doubt? Shubh Madhyanam Guruji. That's so pure Hindi. Even I don't know that much of Hindi. Thank you. Shubh Madhyanam to you as well. Okay. All right. Discuss all questions. I think most of them were quite direct. Do we want to waste the precious 1 hour which we get? Who is your favorite student in current Sri Gosalites? It's very difficult to pick one, Ajay. Don't ask such difficult questions. Everyone who is studying, everyone, whether they are my student or not, every NEET aspirant has my best wishes, my blessings, my love, my care, my affection, everything. I have not attended the last class. Your age, 15 years. My college, IIT BHU. I had been 15 years for the last 10 years. No problem, Navya. No problem. You can attend lecture. Even if you don't get it completely, there is absolutely no reason to panic. All the recordings as such are present on the YouTube. And moreover, once you are here, we'll be teaching everything again. So just sit with a very calm, cool and neutral mind. Okay? And try to grasp as much as you can. If you don't understand anything, there is no reason to panic at all. Will you teach this in offline class? Yes, of course. Chalo bhai, atomic structure mein what are the doubts? I have opened the paper. If anyone has any doubts, which particular question do you have the doubt over here? Can you say class in Zoom? What is the highest in secondary results? In class 11th, I think it was 4 out of, 4 marks got deducted, 436 out of 440, something like that. So the questions were very direct. If you have any doubts, ask it. Otherwise, we will begin with stoichiometry. Shall we start stoichiometry, everyone? Boys and girls? Shall we begin stoichiometry? Very interesting and very important topic. Deflection question. Deflection, which one is that? When atoms are bombarded with alpha particles, only a few in millions suffer deflection. Is this the one? When atoms are bombarded with alpha particles, only a few in a million suffer deflection, others pass out undeflected. This is because nucleus is very small in size. Why most of the alpha particles go straight? Because the nucleus has a very small size, na? Its volume is negligible. That is why most of the alpha particles miss it. It is like saying that suppose I put a tiny dot on this board and I'm asking you to stand 10 meters away from the board and throw a ball so that it hits this dot. So what will happen? Most of the times you will miss it, na? Most of the times you will miss it. So that is the reason why most of the alpha particles, very few alpha particles hit the target and they are deflected. That's it. Chalo, so we will not waste any more time. Let's continue with stoichiometry. So boys and girls, sir, is balancing a part of stoichiometry? No, balancing is a part of another chapter which is known as redox reactions. Okay, boys and girls. So let's quickly begin with today's class. So yesterday's class, everybody, I had given you a glimpse, a brief introduction about what stoichiometry is. So stoichiometry essentially is nothing but analysis of a balanced chemical equation. And I told you that for the numbers which are used for balancing, we use a very fancy term. That term is known as what, everyone? That term is known as stoichiometric coefficients. I hope you remember that, everyone. Okay. So that term is known as stoichiometric coefficients, and the numbers which we use for balancing are called stoichiometric coefficients. And what is stoichiometry all about? Stoichiometry simply means analysis of a balanced chemical equation, right? Now, after this, we also discussed that the basic theme, the basic idea behind any stoichiometry problem is that what do the stoichiometric coefficients tell us about the reaction? Okay, what information a balanced chemical equation is saying to me? What information a balanced chemical equation is giving me? Okay, what a balanced chemical equation is trying to whisper in my ears. You remember all of that? Okay, so beta, balanced chemical equation, in a balanced chemical equation, the stoichiometric coefficients represent the mole ratio. How many grams of beta molarity and all, we have not done that. Please, let's come back to the topic which we are dealing with currently. Okay, you will be taught everything, but not right now. So I was telling you that in a balanced chemical equation, the stoichiometric coefficients represent the mole ratio. They represent the mole ratio in which the reactants are consumed and volume and products are formed. Reactants are consumed and products are formed. They represent the mole ratio in which the reactants are consumed and the products are formed. In a chemical equation, beta, always remember that the reactants will be consumed. Yes, everybody. And the products will be formed. So everybody remembers this, all of you? Boys and girls. Okay, in a balanced chemical equation, the stoichiometric coefficients represent the mole ratio in which the reactants are consumed and the products are formed. So now we are going to begin with today's class with a very, very important concept. Okay, and we are going to derive one equation which will help us in problem solving in all the questions which are related to stoichiometry. So let's get started, everyone. So suppose we have a balanced chemical equation AA plus BB goes to CC plus DD. Here, this is a balanced chemical equation. Capital ABCD represent reactants and products. Capital ABCD represent reactant and products. Okay, and small abcd represent their respective stoichiometric coefficients. So small abcd are the stoichiometric coefficients and capital ABCD are the reactants and products. Now listen to me very, very carefully. I am going to derive a very beautiful relation which will help you in solving all the problems, and I say it with 101% confidence, all the problems related to stoichiometry. So are you all ready, everyone? Are you all ready, guys? Good to go? Okay, so now watch carefully. This is a balanced chemical equation. In a balanced chemical equation, the stoichiometric coefficients represent the mole ratio in which reactants will be consumed and the products will be formed. So now tell me, in this reaction, if I want to write moles of A consumed, CONS means consumed, short form, upon moles of B consumed, moles of A consumed upon moles of B consumed, what is their ratio? Moles of A consumed upon moles of B consumed, what is their ratio? Moles of A consumed upon moles of B consumed, they will be in the ratio A by B. Moles of A consumed upon moles of B consumed will be in the ratio A by B. Dot 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 dot. Equation number one. Okay, very good. Excellent. Most of you have written the right answer. Okay, next equation. Moles of A consumed upon moles of C formed. Moles of A consumed upon moles of C formed. C is the product, so C will be formed. So moles of A consumed upon moles of C formed. Ratio cheppen bhai. Ratio moles of A consumed upon moles of C formed. Ratio A by C. Excellent. Chala baundi. Dot. Equation number two. Okay, one more equation we are going to write. What is that equation? Moles of A consumed. The moles of A consumed upon moles of D formed. Moles of A consumed upon moles of D formed. What is the ratio, boys and girls? What is the ratio, everybody? Yes, I can see lots of correct answers. Well done. Excellent. So what is the ratio, everyone? Ratio is A by D. Dot. Equation number 3. Now I am going to ask you a very extremely difficult question for which you need to have a very high IQ. Only then you will be able to answer it. Okay, you need to have very high IQ. The question is that if I have 3 equations, don't write it. This is just for explanation. This you have to write. What I am going to write right now, that you don't have to write. Okay? You need to have very sharp IQ. IQ more than Albert Einstein to answer this. Okay? So the question is that suppose you are given 3 equations. 3 equations are given. Alpha is equals to beta. Equation number 1. Alpha is equals to gamma. Equation number 2. Alpha is equals to delta. Equation number 3. 3 equations are given. Alpha equal to beta, alpha equal to gamma, alpha equal to delta. These 3 equations are given to you. Okay? So my question to you is, can I write alpha equal to beta equal to gamma equal to delta? Is it correct? Very high IQ needed to solve this. IQ more than Albert Einstein. If this is given, can I say that alpha is equals to beta is equals to gamma is equals to delta? Yes, so you all are very sharp people. Yes, well done boys and girls. I am dealing with such smart people in my life. I am overwhelmed. Okay, very good. So I will clean this. Now, pay attention. High IQ needed, Nagaraju. What happened? Okay, so now, so pay attention, everybody. Look at equation number 1. If I cross multiply, you understand? T cross multiply. Okay? So if I bring this A over here and take this B that side, okay? So equation number one will become, I will not write it, I will just explain it to you on the board. You also don't need to write it. Moles of A consumed upon A is equals to moles of B consumed upon B. Maybe one of them I can write for your mental satisfaction. Sir is writing everything, paying attention to the details. Moles of A consumed upon A is equals to moles of B consumed upon B. Tell me, are you able to understand this? Crisscross, cross multiply. A bring in denominator, this take in numerator. So moles of A consumed upon A is equals to moles of B consumed upon B. Understood? Moles of A consumed upon A is equals to moles of B consumed upon B. Similarly, for this one, if I do crisscross, I will get moles of A consumed upon A, moles of A consumed upon A is equals to, just a minute, is equals to moles of C formed upon C. Moles of A consumed upon A is equals to moles of C formed upon C. And similarly, boys and girls, here if you do cross multiplication, you get moles of A consumed upon A, moles of A consumed upon A is equals to moles of D formed upon D. Moles of D formed upon D. Is this understood by everybody, entering the brain or not? Bolo. Everybody can feel this, what is happening. So now look at this side of the board. Are you getting alpha equal to beta, alpha equal to gamma, alpha equal to delta? Hatmika, please post your doubt. Alpha equal to beta, alpha equal to gamma, alpha equal to delta. So by combining alpha equal to beta, this is alpha. Alpha equal to gamma, yes, this is it. Yes, you can call it ABCD method. Name is not important, yaar. The work is important. Don't focus on the name. Alpha equal to beta, alpha equal to gamma, alpha equal to delta. So combining this, I can write moles of A consumed upon A is equals to moles of B consumed upon B is equals to moles of C formed upon C is equals to moles of D formed upon D. Okay, for any balanced equation of the type A plus B goes to C plus D, for all the reactants and products, please try to understand the form of this equation. This is super duper, chala important. Okay. So for any balanced equation, I can write buffering, not buffering. My speed is so much that the camera is not able to capture. Moles of A. Is it coming like that? Moles of A upon. Is it coming like that, or is it normal? Is it normal, guys? I can buffer in live. That is my ability. In a live class, I can buffer. That slow-mo dance is there, na? Okay, it's fine, na? Okay, so now pay attention, everybody. So for a balanced chemical equation, AA plus BB goes to CC plus DD. AA plus BB goes to CC plus DD. Okay? Please try to understand the form of this equation. So this is a balanced chemical, and for all the reactants and products, for all the reactants and products, we can write moles upon stoichiometric is equals to moles upon stoichiometric is equals to moles upon stoichiometric is equals to moles upon stoichiometric. If it is a reactant, then moles will represent moles consumed, and if it is a product, then moles will represent moles formed. Are you able to understand this, everyone? So this is your single most important, because if you remember in the last class, just before ending the class, I told you that a problem of stoichiometry is nothing but a problem of ratio and proportion, which you have solved in class 9th and 10th. Ages of Ram and Shyam are in the ratio 2:3. Ram is 10 years old. How old is Shyam? You have done these kind of problems, okay? So stoichiometry problem is like that only. Information about any one of the reactants or products would be given. Ki bhai, this much B consumed. So how much C formed? So you will use this part of the equation. This much C formed. How much D formed? So you will use this part of the equation. This much B consumed. How much D formed? So you will use this part of the equation. Is this understood or not? So in any problem of stoichiometry, information about one of the reactants or products is given. Ki bhai, this reactant, this much consumed, or this product, this much formed. And for other, you have to find ki bhai, B consumed this much. So D formed how much? A consumed this much. So C formed how much? So this is the single most important concept, equation, formula, whatever you want to call it. Personally, this is a personal thing, hai na? Not official, not formal. I call this equation as the. So if you find anyone in this world who knows this name, then you can be sure that they are a student of Shivam sir. Personally, I call this equation as the grandpa equation. Grandpa equation. This is the name given by me. I call it as the grandpa equation. Grandpa equation. Moles of A upon A, moles of B upon B, moles of C upon C, moles of D upon D. Grandpa equation. Okay? Now you won't ask me, sir, why? If I am calling it grandpa, then some reason must be there. ना ऐसे थोड़ी ना grandpa बोल दिया है, कुछ तो reason होगा. Ask why? See, the why is very strong over here. Okay? As kids, when we were a bit younger, like below in single digits, 7 years, 8 years, maybe 10, 11. So as kids, we are normally very curious, and we tend to ask a lot of questions, sometimes silly ones also. And usually most of the times what happens especially in joint families, that parents tend to get irritated after a while if you keep on bothering them with lots of silly questions. So personally with me, whenever I was in such a situation that I had some lots of silly questions. So there always used to be a Dadaji at home, grandfather, who would always answer all our questions, no matter how silly they are. Grandpa answers all our questions, no matter how silly they are. Mom and dad may sometimes get irritated, but grandpa never gets irritated. Understood, everyone? So that is why I call it the grandpa equation. Because just like your grandpa, this equation will answer each and every question related to stoichiometry. So that is the reason why I call it the grandpa equation. This equation will answer each and every question based upon stoichiometry. And that is the reason why I call it the grandpa equation. Just like our grandpa answered all our questions, similarly, this equation will answer all the questions of stoichiometry. So are you ready for the examples now, everyone? Are you ready for the examples, everybody? Okay, very good, very good, very good. Let's begin. Let's begin. First one coming on your way. First example. CaCO3 means CaCO3. Solid on heating, delta sign means heating. Gives you CaO solid plus CO2 gas. CaCO3 on heating forms CaO plus CO2. Okay? What is the molar mass of H2O? You are asking this after so many days. It is 18 gram per mole. Is that a question? Now question is find the volume of CO2 gas. Find the volume of CO2 gas produced at NTP upon heating 200 gram of CaCO3. So we will be doing all the analysis in terms of moles. Okay? So calculate the molar mass of CaCO3. How many grams of NaCl are needed to make 250 ml? Beta, whatever is your name, CSK Love 7. This question which you are asking is not related to stoichiometry. For this you need to know a topic called concentration terms. So that is not a part of your syllabus for gift classes. So have patience. Everyone in Gosalites knows concentration terms. Okay? And you will be taught in great detail. So have patience, right? I choose to reply because you are posting this same question for the 4th time, I guess. All right? So have patience. Focus on what you are being taught right now. And there is a time for everything. Na? You are born, then you learn to crawl, then you learn to stand up, then you learn to walk, and then you learn to run. And then you learn to fly. You can fly, I hope. Okay, so now the point is, so let's not keep things out of turn. Everything has a schedule. Okay, so you need to stick to that. You need to respect that. All right. So now over here we will be having first of all, I have been asked that from 200 gram of CaCO3, how much CO2 would be obtained? Okay. So first of all, I will calculate the moles of CaCO3. Moles of CaCO3 will be equals to given mass, which is 200 gram, upon molar mass. Molar mass of CaCO3 beta will be 40 for calcium, 12 for carbon. 44.8 liter is absolutely correct. 12 for carbon and 16 threes are 48. 48 plus 12, 60 plus 40, 100. So molar mass of CaCO3 is 100 gram per mole. So once you solve this, what do you get from here? You get 2 moles. You get 2 moles. So now from 2 moles of CaCO3, how much of CO2 would be obtained? So I will have moles of CaCO3, moles of CaCO3, moles of CaCO3 consumed. If it is a reactant, it is understood that it is consumed. I need not write consumed every time. Okay. So moles of CaCO3 upon 1, because you see na moles upon stoichiometric. So stoichiometric N bhai. Stoichiometric N 1. Okay. And I have to solve for what? I have to solve for CO2. So CaO not needed in the question, not needed. CaO I will not bother about. So I will write moles of CaCO3 upon 1 is equals to moles of CO2 upon 1. Okay, is equals to moles of CO2 formed upon 1. This is consumed upon 1. So moles of CaCO3 is how much, bhai? Moles of CaCO3 is 2 mole. So put 2 moles over here. So moles of CO2 produced will be equals to 2 mole. Once you put 2 over here, are moles upon stoichiometric na? moles of CaCO3 upon stoichiometric is equals to moles upon stoichiometric. Could you please share the gift class syllabus? You will be notified every week. Don't worry. Moles of CaCO3 upon 1 is equals to moles of CO2 upon 1. Moles upon stoichiometric is equals to moles upon stoichiometric. This is the idea. अरे भैया समझ में आया? हाँ ना, yes no, आउन उद्दू. Beta, because CaO Chaitanya neither given in the question nor asked. If I have to, if in the question I have been given data about A and I have been asked about C, so I will write A upon A equal to C upon C. Why bother about B? If it is not required, then I will ignore it. I will ignore it. As simple as that. Okay? So now what we'll do is that moles of CaCO3 upon 1, moles, because CaCO3 coefficient is what? 1 over here, and CO2 coefficient is also 1 over here. So moles of CO2 produced will be how much? Because CaCO3 is 2 moles, na? So put 2 over here. So moles of CO2 will be equals to 2 moles. And now for 2 moles of CO2, you try to find out the volume. So what will be the volume, everybody? What will be the volume? We will find out from Avogadro's hypothesis. So 2 moles into molar volume. Molar volume is how much, everybody? 22.4 liter per mole. 22.4 liter per mole. Yes, so mole cancel. And what is the volume we are getting from here? 44.8 liters. 44.8 liters. Chalo, next question, let's go for it. Next question, are you ready, everybody? Let's practice some more examples. I'm sure you will understand. Some of you may be having few doubts. Let me take more examples. Okay? Chalo, next one, everybody. Next one is, equation is given 2 mg plus O2 goes to 2 MgO. Find mass of Mg which reacts with 2 mole of O2. So if 2 mole of O2 are consumed, magnesium atomic mass is 24. Magnesium atomic mass is 24. Find mass of Mg which reacts with 2 mole of O2. So apply Grandpa equation on Mg and O2. And if 2 moles of oxygen will be consumed, then how many moles of Mg will be consumed? If 2 moles of oxygen is consumed, then how many moles of Mg will be consumed, everybody? So I will apply Grandpa equation on Mg and O2. So moles of Mg consumed upon 2. Moles of Mg consumed upon 2 is equals to moles of O2 consumed upon 1. Moles of O2 consumed upon 1. Okay, moles of Mg upon 2 is equals to moles of O2 upon 1. This is the Grandpa equation. And O2 any moles consumed? O2 any moles consumed? 2 mole. So in place of moles of O2, I will be writing what? I will be writing 2. So by moles of magnesium consumed will be 2 into 2. So 2 into 2 कितना हो गया? How much? 4 mole. Moles of O2 consumed any 2 mole. So 2 mole into 2 is 4 mole. Magnesium 4 moles will be consumed, and what will be the mass of magnesium? Mass will be equals to 4 multiplied by molar mass of magnesium. Molar mass of magnesium how much? 24 gram. So this is 4 into 24, that is 96 gram. 96 gram. That's the answer. Very good. Well done. How many of you got 96 gram answer? $96 answer, everybody. Good, 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 good. Very good, very good, very good. Excellent, 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 everyone. Amazing. Very good. Good, very good, excellent. Ready for the next problem, boys and girls? Ready for the next problem? Okay, next problem. 4Al plus 3O2 goes to 2Al2O3. 4Al plus 3O2 goes to 2Al2O3. Find mass of O2 consumed. Find mass of O2 consumed if 9 gram Al is consumed. Aluminium atomic mass is 27. Chalo, solve it. Take a few minutes, solve it quickly. Find the mass of O2 consumed if 9 gram Al is consumed. Chalo, everybody try it fast. Do it quickly, everyone. Quick, 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 quick. Chalo, everybody solve it quickly. Think, think, think. Try to do it. I am searching for the next question for you. See, if you apply grand power on aluminium and O2, if you apply grand power on aluminium and O2, so moles of aluminium consumed upon 4, moles of aluminium consumed upon 4 is equals to moles of O2 consumed upon 3. Moles of aluminium consumed upon 4 is equals to moles of O2 consumed upon 3. Now, what is moles of aluminium consumed? Moles of aluminium consumed is given mass by molar mass. Once again, given mass by molar mass. So given mass by molar mass is how much, bhai? It is 1 by 3 mole. 1 by 3 mole. 1 by 3 mole. So in place of moles of aluminium, I can put how much? 1 by 3. In place of moles of aluminium, I can put 1 by 3. This many moles of aluminium is consumed. So put 1 by 3 over here. So you will get, once you put 1 by 3 over here, you will get, I am solving here, okay? 1 by 3 into 4. 1 by 3 into 4 is equals to moles of O2 upon 3. 3 cancel. Moles of aluminium 1 by 3 upon 4 is equals to moles of O2 upon 3. 3 and 3 cancel. And therefore moles of O2 is equals to 1 by 4 mole. 1 by 4 mole. And now you have to find what? You have to find the mass of O2. So mass of O2, what is the molar mass of O2? What is the molar mass of O2? O2, not O. O2, molar mass of O2. Molar mass of O2, this is moles of O2. O2 molar mass 32 gram per mole. Very good, boys and girls. Excellent. So 1/4 mole multiplied by 32 gram per mole. Mole cancel. Answer is how much? Mass of O2 is 8 gram. 8 gram is absolutely the correct answer. Well done, boys and girls. 8 gram. Okay, everybody. Next problem. Next problem. Are you ready? Next problem. Are you ready? Okay. Everyone knows what are hydrocarbons. One word of advice. One word of advice. Before applying grandpa, check whether the equation is balanced or not. Check whether the equation is balanced or not. So you have C3H8 plus O2. Compounds containing carbon and hydrogen are called hydrocarbons. Compounds containing carbon and hydrogen are called hydrocarbons. Okay, and they react with O2, undergo combustion to produce CO2 and H2O. Sir, why are you going up fast? Beta, if I go slow, then it will start buffering, na? So that is why I have to maintain some basic pace. So C3H8 plus O2 goes to CO2 plus H2O. So question is that, last question for today's class, find volume of O2 required for total combustion. O2 required. Find volume of O2 required at NTP for total combustion of 3 mole propane. But please note this equation is not balanced. Please note this equation is not balanced. So before applying grandpa, check whether the equation is balanced or not. So this is not balanced. So you have to balance it first of all. So there is 3 carbon over here. There is 3 carbon over here. To balance it, I will put 3. To balance it, I will put 3. There is 8 hydrogen over here. To balance it, I will put 4. 4 2s are 8. And now oxygen becomes how much? 3 2s are 6 and 4 10. So what will be the coefficient over here? What will be the coefficient over here? 5 O2. Very good. 5 2s are 10. Balancing is clear, everyone? Balancing is clear, everybody? Okay, now apply grandpa. So before applying grandpa, check whether the equation is balanced or not. That's very important. Okay. So now you can say moles of C3H8. Everybody pay attention. Moles of C3H8 upon any coefficient any 1 is equals to moles of O2 consumed upon coefficient 5. Understood, everyone? Now in place of moles of C3H8, you put 3. So put 3 over here. So moles of O2 consumed will be 5 into 3, 15. 5 into 3, 15. Is this okay, everybody? And now from here you will calculate the volume of O2. So volume of O2 will be equals to 15 moles multiplied by 22.4 liter per mole. Mole cancel. Mole cancel. Yes, everybody is giving good answers. Yeah, very good. I am afraid that you will start teaching me once you are here at the campus. I have this anxiety. I will be jobless. Smart kids, well done. Well done, everybody. Good. 22.4 into 15. ठीक है. So that is multiplication. 15 fours are 60. Carry over 6. So 36. Yes, 336 liters is absolutely correct answer. Is this okay, everyone? 336 liters. Okay, bhai. So that will be all for today. Tomorrow's class, we'll do some more practice and we will begin with the next topic, that is limiting reagent. Okay, champs. Thank you, everybody. Thank you, boys and girls. Bye. Okay, I'll see you tomorrow. Bye. Take care. Have a nice day. Take care at home. Tomorrow we'll continue from here. Okay? Next concept we will start limiting reagent. Chalo, bye everybody. Thank you.